In this module, we are going to look into the construction and the working of an electric generator. It consists of an armature ABCD, which is being connected to two slip rings R1 and R2, which are insulated inside, which is in turn being connected to two stationary brushes. So we are going to look into the working of an electric generator. The principle of an electric generator is a changing magnetic field induces current in the circuit. How do we change the magnetic field? By giving a motion to the armature. So we are rotating this armature clockwise. So now look at this armature ABCD. It is being connected to AB is being connected to ring R1 and CD is being connected to ring R2. R1 and R2 moves along with the armature. This R1 is in turn connected to the brush B1, which is stationary, and R2 is being connected to B2, which is again stationary. So these brushes remain stationary, and always R2 is being connected to B2 and always R1 is being connected to B1. Now let us consider, so this brushes B1 and B2 are being connected to a galvanometer. The purpose of a galvanometer is to detect the presence of current. It will not calculate the total amount of current. It will just to find out whether there is current flowing in the circuit or not. So now for that, what we are going to do is, we are just going to rotate this armature clockwise. So we are giving mechanical energy. So mechanical energy, we are rotating it clockwise. So when you are rotating it clockwise, AB moves up. So when AB is moving up, the force is upwards. And then you have the magnetic field to be moving from north to south. So your magnetic field is in this direction. So the direction of the induced current can be calculated or can be found out with the help of the Fleming's right hand rule. So your force is upwards and then your magnetic field is in this direction. Yes. Now how is your current? The current is in this direction. So the current is flowing from A to B. So it's moving along this direction. So which means that the current moves from A to B to C to D. Yes. So now here at this particular position, you have your force in this direction, your magnetic field in this direction. So which means both are perpendicular. When both are perpendicular, you have the maximum current to be induced. Now when it is being lifted up, your angle will change. In that case, the current that is induced will also be reduced. And when it is coming to this position, it comes to 0. Yes, so it comes to 0 because your direction of motion is in this direction. The direction of force is in this direction. Your magnetic field is also in the same direction. Both are parallel. And therefore, the current that is induced will be 0. Now look at the graph which we have drawn. So in this position, it is maximum. And then it is coming down to 0. So it is when it is perpendicular in this position, you have the current to be induced to be 0. Now as it is further rotated, yes, so now in this position we said the current is flowing from A to B to C to D. So as it is moving through D, we know CD is being connected to R2. So R2 is connected to B2. So now you have the current be flowing from B2 to B1. Now after this position, yes, when it is further turned, yes, we can see that the motion is downwards. The force is downwards. You have the magnetic field again to be on the same direction, north to south. Then your current is flowing from B to A. So when the current is flowing from B to A, A is being connected to brush B1. Yes, so which means that the current is flowing from B1 to B2. So initially it was flowing from B2 to B1 and now it is flowing from B1 to B2, which means that there is a change in the direction of current. So initially if your galvanometer was turning towards the right, now it will turn towards the left. So it will come to the maximum position again when it is perpendicular. Then when you rotate it again, it comes to 0. So this happens continuously. So from this we can see the graph initially it will be maximum, it comes to 0 and then again it goes to maximum in the opposite direction and then again it decreases. So this is continuous. So you get a sine wave and it is periodical. Such type of current that is being produced is called as the alternating current and this generator is called as the AC generator. Hope you must have understood.